Hello everyone, welcome back to our channel Problematical. Let's discuss exercise 1.4 from chapter 1 sets from class 11th maths NCERT. First question is, find the union of each of the following pairs of sets. Now to calculate union, your sets should compulsorily be given in roster form. If it is not, we'll try and convert it into roster form and then solve it. So first part is x is 1, 3 and 5. And y is equals to 1, 2 and 3. X union y is written like this. U is a union symbol which will be equal to all the elements in x and y. So you have 1 present in both written once, 2 present in y, 3 present in both, and 5 present in x, which covers all elements present in x and y. Second, A is equals to E, I, O, Q, and B is equals to A, B, C. Another approach you can take is write all the elements of either one of the two sets. And writing all the elements of A because they are a larger number. There are 5 elements of A, E, I, O, U. And then write all those elements in B which are different from A. So A is common, it's already mentioned, leave it B. B and C are not mentioned in A, so I'll write just B and C, be done with it. If you have to, you should always write things alphabetically or in ascending order in case of numbers. So it would be A, B, C, E, I, O, Q. Good. A is a set of all x such that x is a natural number and a multiple of 3. So all natural numbers which are multiple of 3. So it would be 3, 6, 9, 12, 15, and so on. Second, B is a set of all x. X is a natural number less than 6. Natural numbers less than 6 would be 1, 2, 3, 4, and 5. So here your here A union B will be equals to 1, 2, 3, 1, 2, 3, 3 present over here as well, 4, 5, and then 6 onwards, all the multiple of 3 present in A. So it is 6, 9, 12, 15, and so on. Next. A is a set of natural number 1 less than x less than equals to 6. That means x lies between 1 to 6, not including 1 but including 6. So A is equals to 2, 3, 4, 5, and 6. B is equals to natural number 6 less than x means not including 6 but x is greater than 6, which would be from 7, and less than 10 not including 10 means 9. So 7, 8, and 9. A union B will be equals to 2, 3, 4, 5, 6, all elements of A, and then 7, 8, 9, all elements of B. Here I should have written A union B. Fifth, A is 1, 2, 3, B is 5. So if B is 5 means there is no element in B, in which case your A union B will be equals to A itself, 1, 2, and 3. Union stands for uniting. U stands for union, and which is like uniting. That means bringing together all the elements of the involved sets. Second, let A is equals to A, B, and B is equals to ABC. Is A a subset of B? Now, any set is a subset of another set if all the elements of the left-hand side set are present in right-hand side set. Now, A belongs to A and A belongs to B. Similarly, second element of A, which is in A, also is present in B. Therefore, A is a subset of B. What is A union B? If you unite A with B, let's write all the elements of A, which are A comma B. In B, A and B are already written. You have to write C. Now, by observation, this is B. So, A union B will be B when A is a subset of B. That's also a property. If A is a subset of B, then A union B is equals to B and A intersection B is equals to A. That's a rule. Next, if A and B are two sets such that A is a subset of B, then what is A union B? If A is a subset of B, then we know that A union B is equals to B from the previous question. You can explain, if this comes around for more than 1 mark, then you can explain it with the help of example. Take any set A with certain elements, set B such that A is a subset of B, and thereby calculate A union B to give you the answer B. Next, if A is equals to 1, 2, 3, 4, B is equals to 3, 4, 5, 6, and C is equals to 5, 6, 7, 8, D is equals to 7, 8, 9, 10, find A union B. A union B will be uniting the sets of A and B. Let's write all these elements of A. 1, 2, 3, 4. B, 3 present, 4 is present, 5 and 6 should be included. Next, A union C. A, all elements should be mentioned, 1, 2, 3, 4, and then C. C involves 5, 6, 7, 8. So these are different elements. By observation, we can see that A and C are disjoint sets with no element in common with each other. B union C. B union C will be, write all the elements of B, 3, 4, 5, and 6. In C, 5, 6, 7, 8. 5, 6 are already mentioned, 7, 8 are to be added. B union D. B union D means all the elements of B, 5, 6, 7, all the elements of B, 3, 4, 5, and 6, and all the elements of D, 7, 8, 9, 10. B and D are disjoint sets. A union B union C. Now we know that this can be written as A union B in one bracket, union C. Now A union B is already written over here. Union B is already calculated over here. So from 1, we are substituting this. We have 1, 2, 3, 4, 5, 6. And you're uniting it with C, which holds the value 5, 6, 7, and 8. So uniting them means you mention all the values of the first set as it is. Now second set. 5 present, 6 is already written, 7 and 8 are to be added. This is A union B union C. Next, A union B union D. Now A union B union D will be equal to, again, A union B and uniting it with D. So this is 1, 2, 3, 4, 5, and 6. Uniting with D, 7, 8, 9, and 10. So this would be writing first set's elements as it is. Adding 7, 8, 9, 10 are different elements, so adding them to the set or including them in the set. You do not typically add them, you should include them. B union C union D. B union C union D. So we know that B union C we just calculated. We're uniting it with D. This is B union C. 3, 4, 5, 6, 7, 8, 9, 10. Uniting it with D, 7, 8, 9, 10. So write the first elements as it is, 3, 4, 5, 6. What did I do? Oh, right. It's 3, 4, 5, 6, 7, 8. So I shouldn't have mentioned 9 and 10. United with D, 7, 8, 9, 10. So writing first elements as it is, 7, 8, 9, 10. 7, 8 I already mentioned, and include 9, 10. Those are your answers. Next. Find the intersection of each of the pair of sets of question 1 above. Intersection of each of the pairs. So in question 1, we went with union of all these sets. Now we'll try and calculate the intersection of all these sets. And the first problem, your A is equals to 1, 3, and 5. Sorry, 1, 3, 5, and x is equals to 1, 3, and 5, and y is equals to 1, 2, and 3. X intersection y would be equal to elements which are common in both. Only element 3 is common in both. So that is the intersection value. 2. A is equals to A, E, I, O, U. And B is equals to A, B, C. Therefore, A intersection B will be equals to only A element is common in both. So it is A. Third, A is equals to x is a natural number and a multiple of 3. So you have 3, 6, 9, 12, and so on. And B is a natural number which is less than 6. 1, 2, 3, 4, 5. So in intersection, you have to find the elements which are common in both. The only element you can find common in both is 3. Up till now, the first 3 sets are intersection sets are singleton sets. Fourth, A is a set of set of all x, such as x is a natural number and x lies between 1 and 6, excluding 1, including 6. So it is 2, 3, 4, 5, 6. Second, B is x value natural number between 6 and 10, not including either of the two values. So it is 7, 8, 9 are the elements. A intersection B would be elements which are common. 2, 3, 4, 5, 6, 7, 8, 9. There's nothing common over here. So this is a 5, or you can write another set. 5. A is 1 to 3 and B is 5. The only element common in these, there's nothing common in it. We can easily say that A intersection B is equals to 5. Next. If A is equals to, A and B are given, C and D are also given, find these values. First, A intersection B. Elements which are common between A and B are 3, 5, 7, 9, 11, 7, 9, 11, 13. So 7 is common, 9 is common, and 11 is common. So it will be 7, 9, and 11. B intersection C. 7, 9, 11, 13, 11, first element is there, 13, second element is there, 15, third element is not there. So 11 and 13 are common. A intersection C intersection D. So A intersection C in one bracket, intersection D outside. By observation, A and C, there's only 11 element is common between A and C. You have to intersect it with D. Those values are 15 and 17. So there is no element common in them. Fourth, A intersection C. As we just calculated, A intersection would be 11. D intersection D. So B intersection D would be B 7, 9, 11, 13. D is 15, 17. There's nothing common in it, so it is 5. 6th, A intersection B intersection C. Now B intersection C is already calculated. So A is 3, 5, 7, 9, 11. Intersection with B intersection C, which is 11 and 13. So the only thing common is 11. 7th, A intersection D. Now A intersection D is A stands between 3 and 11. D has elements 15 and 17. There's nothing common in it. So this is 5. 8th, A intersection B intersection D. Now we know that B intersection D is 5. So it is A intersection 5. What is common between A and 5? 5. Hold on. It says union in 6th question. Let's resolve these as well as union over here. So this is A intersection B union C. A intersection B union C would be uniting B and C, which is 7, 8, 7, 9, 11, 13. 11 and 13 are common, then 15. What is common between A and these values? We have 3, 5, 7, 9, 11. 7, 9, 11 are repeated over here. So 7, 9, and 11. Here, A intersection B union D, uniting B values and D values. So write all the elements of B first. 7, 9, 11, 13, and then all elements of D, 15 and 17. This is equals to A, all elements 3, 5, 7, 9, 11. The common elements would be 7, 9, and 11. Ninth, A intersection B intersection B union C. So A intersection B from 1, we have 7, 9, 11. Intersection B union C. B union C is over here, which means this is B union C. Intersection of 7, 9, 11, 13, 15. To find common in this, we have 7, 9, 11. Tenth, A union D. Did we calculate A union D? No. So A uniting with D, which is 3, 5, 7, 9, 11, 15, 17. This value intersection B union C. B union C we calculated in the previous question here. B union C ये वाला. So यहाँ पर we'll rewrite it 7, 9, 11, 13, 15. This will give you 7, 9, 11, 15. Next question. If A is a set of natural numbers, B is a set of even natural numbers, C is odd natural numbers, and D is a set of prime numbers, then find A intersection B. What is common between A and B? Let's write it in the rooster form. So A is all natural numbers, so 1, 2, 3, 4, and so on. B is even natural numbers, 2, 4, 6, 8, and so on. C is odd natural numbers, 1, 3, 5, 7, and so on. And D is prime numbers, so 2, 3, 5, 7, 11, and so on. Now, what is A intersection B? What is the common value between A and B? Natural numbers means even plus odd, and here you have even numbers. So obviously it would be even numbers, which is, you can write it either B, or you can write this whole statement even natural numbers over here in Z-beta form. A intersection C. Again, A is set of natural numbers, C is set of odd numbers, so obviously the common element would be C itself, because C is a subset of A over here. Second question. First question, B is a subset of A. 3. A intersection D. A intersection D. A is a set of natural numbers, D is a set of prime numbers, D is a subset of A, therefore the answer again would be D. Fourth, B intersection C. B is even numbers, C is odd numbers, there's nothing common in it. So B intersection C would be 5. B intersection D. B is set of even numbers, D is set of prime numbers, 2 is the only even number, rest all numbers will be odd numbers. So 2 is the only value which is common. B intersection D is equals to 2. C intersection D. C is a set of odd numbers, D is a set of D is a set of prime numbers, and we know that 2 is the only prime number which is even. So apart from 2, the rest of all the rest of odd numbers will come in C intersection D. Common elements will be from C onwards prime numbers which are not 2. So you can call this as D minus 2, or you can call this as odd prime numbers. So in Z-beta form, you'll write something like, this is a set of all x such that x is an odd prime number. Which of the following pairs of sets are disjoint? Disjoint sets are those sets which do not have anything in common. So what we'll do is we'll find the intersection of the two sets in each example and see whether your answer is phi or non-zero. Or it is at least a singleton set. So let A is equals to 1, 2, 3, 4. We'll convert everything into roster form to be able to calculate A intersection B easily. Natural number which lies between 4 and 6, including both 4, 5, 6. Do you have anything in common? A intersection B by observation is 4, which is not equals to 5. Therefore, A and B are not disjoint sets. Now, both are already given. We're calculating A intersection B. Both sets are in roster form. A, E, I, O, U, C, D, E, F. E is common. Element E is common in both. So this is E. Not equals to 0. Sorry, not equals to 5. Therefore, A and B are not disjoint. X is an even number, even integer, and X is an odd integer. So A is a set of even integers, B is a set of odd integers. Now we know that no even integer can be an odd integer. So no element from A or B will be common. No, there is no integer which can be called as both even and odd. So since nothing is common, we can easily say that A intersection B will be 5. If this is 5, then A and B are disjoint sets. A A is 3, 6, 9, 12, 15, 18, 21. B is given, C, D are given. You have to find the difference, A minus B. Now, A minus B would be considered, you can consider this as in terms of a formula, which is A intersection A subtracted with A intersection B. That means all the elements which are common between A and B should be subtracted from A to get A minus B. Or it can be considered as A intersection B complement. For this, you'll have to first calculate B complement. For that, you should know the universal set. Since there is no universal set present, we'll refer with this particular formula, which is all the elements which are common between A and B should be subtracted from A. By observation, A intersection B, here in this particular problem, A intersection B is equals to 3, 6, 9, 12, 15, 18, 21, 4, 8. Let's consider the second element, 4 not present. 3 is a multiple of, A set is a multiple of 3. So from B set, which elements are multiple of 3? 12, that's it. 12 is present in A as well. So A intersection B is 12. Therefore, A minus B will be equals to element, you have to remove 12 from there. 3, 6, 9, 15, 18, 21. A minus C. So all the elements which are common between A and C would be, observe, C is all even numbers between 2 and 16 including both. So 2, 4, 6 and A is multiple of 3. So 6 is a multiple of 3, 12. You're finding multiple of 3s in C, 6 and 12. Amongst 6 and 12, 12 is common between A and C. So removing 12 again, you get 3, 6, 9, 15, 18, 21. Sorry, 6 is also common. So remove 6 as well. Yeah. A minus D. So A minus elements which are common between A and D are 5, 10, 15, 20. So 15 is common. 15 is a multiple of 3. This will be equals to 3, 6, 9, 12, 18, 21. B minus A. Common elements between B and A, we already calculated this 12. So remove this 12 from B. So 4, 8, 16, 20. C minus A. All elements of A which are common between C and A should be subtracted from C. So C minus A is equals to 2, 4, 8, 10, 14 and 16. D minus A. D minus A. 15 is common in both. So D minus A will be equal to 5, 10, 20. 7th. B minus C. B and C. B and C have 12 in common. So 4, 8, 16, 20. 8th. B minus D. Subtracting D elements from D. Now here you have 20 common. That's it. You do not have anything else in common. So it will be 4, 8, 12 and 16. You've removed 20 because it's common between B and D. Next. C C minus B. Between C and B, you have 8 common. Just give me a second. In the 7th question, let's resolve the 7th as well. B minus C. B and C. The common elements are, let's recheck. 4, 8, 12, 16. Yeah, sorry. 4, 8, 12, and 16 are common. So B minus 4, 8, 12, and 16. All 4 elements are common between B and C. So you're left with only 20. C minus B. Again, all these 4 elements are common. 4, 8, 12, and 16. So removing these elements from C, we get 2, 6, 10, 14. D minus B, which is D minus common elements between D and B are 20. Five, 10, and 15. 11th, C minus G. So it is C minus, here 5 is not present, 10 is present, 15 not present, 20 not present. So 10 is the only thing which is common. 2, 4, 6, 8, 12, 14, 16. D minus C. Amongst D and C, again, 20 is common. So D minus 20. This is equals to 5, 10, 15. One second, it is C, right? Let's recheck. I considered B. So D and C, 5 is not present, 10. 10 is the one which is common, 15, 20 is not present. 10 is common, so you write 5, 15, and 20. As you can see, there can be confusion in these questions. You have to be patient and you always have to double check your answers. If x and y are given, find x minus y. So you can also solve these questions using Venn diagrams, but it's not specifically required in the question. Venn diagrams takes time to draw. So it is time constraint, time is a constraint, and you can write these in the form of sets, roster form, else you can draw a Venn diagram. So x minus y, which would be x minus intersection of x and y. X minus x intersection y. This is x minus, what is x intersection y? Let's consider y. F is not present, B is present, D is present, G is not present. So B and D are common. So you're left with E and C. Y minus X. Y minus B and D. This is equals to F and G. X intersection Y. E and C are common elements. Next. 11th. If R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? Now, real numbers are a combination of rational numbers plus irrational numbers. There's no other element there's no element in real numbers which is neither rational nor irrational, or both rational or irrational. However, rational numbers can be written in the form of irrational numbers at times, but they will still end up to be rational numbers. So if R is a set of real numbers and Q is a set of rational numbers, then what is R minus Q? By taking all the rational numbers away from real numbers, you'll always be left with irrational numbers. So answer would be a set of, or R minus Q. We know that subtraction or difference in sets follow closure property. So R minus Q, the difference of two sets would lead to a set, is a set of irrational numbers. State whether each of the following statement is true or false. Justify your answer. First, 2, 3, 4, 5 and 3, 6 are disjoint sets. As you can see, if you consider A is equals to 2, 3, 4 and 5, B is equals to 3, 6, your A intersection B is equals to element 3, which is not equals to 5. Therefore, A and B are not disjoints. Therefore, it is false. 2. A, E, I, O, U, A, B, C, D disjoint sets. Again, we can clearly see that A is common. So A intersection B is equals to A, not equals to 5. Therefore, not disjoint. Hence, the statement is false. 2, 6, 10, 14 and 3, 7, 11, 15 are disjoint sets. There's nothing common in it. So A intersection B is 5. Therefore, statement is true because the two sets are disjoint sets. Fourth, 2, 6, 10, 3, 7, 11 are disjoint sets. This is also true, same as the third case. So this concludes your exercise. Thank you.